Well, I cut 2 1/2, so I think it's probably around 10, something like that. Maybe less. Maybe less, because one of the problems you got to find all the roots, and that takes a while. So, okay, number 6. I'm here with period 4, talking about these review questions for our test tomorrow. All right, the day before prom. Woo! So, let's go ahead and do a long division problem. We have x minus 2 is our divisor. And we have x cubed minus 2x squared plus 4x plus 4 is our dividend. Now, we're not doing number 7, but I just want to show you in number 7 where many of us would probably mess up. There's no cubes, so you need to put a placeholder, 0x cubed, if you were doing number 7. All right, so don't forget placeholders if it's missing any. Okay? All right, so how many times does x go into x cubed? X squared times. So I'm going to write x squared. Now, personally, as I showed you guys when I taught you this, I put it on top of the other squared, but it doesn't really matter. All right, what's x squared times x? X cubed. What's x squared times negative 2? Negative 2x squared. And we're going to do what with long division? We always subtract. Now, this is something that's interesting. I don't think it's ever happened with the problems we've done together. We obviously know x cubed minus x cubed should be 0. We did that on purpose. But what about negative 2x squared minus negative 2x squared? That's also 0. What? So I'm going to bring down 4x plus 4. So our quotient, our answer, is going to be having a missing term as well. All right? It's not a bad thing. It's just how it worked out. How many times does x go into 4x? So I'm going to write, notice where I read it, plus 4. So we have 4x. What's 4 times negative 2? Negative 8. Subtract. 4 minus negative 8 is positive 12. Oh, yeah. Subtracting a negative is actually addition. So we have 12. So the answer is going to be x squared plus 4. And then what is 12? So plus 12 over x minus 2. That is it. Questions on long division? No questions on long division? Okay. That was number 6. Who's got another one? Number 1. All right. Let's go up to number 1. All right. Find all the zeros. Number 1. Come on. There we go. All right. Number 1. Now, it's really nice that number 1 is already factored. I hope that I was nice enough to give you a question that's already factored. Let's hope, right? Yes. I mean, I don't have to. Okay. So, to find zeros, you set each of them equal to 0. Now, I was trying to explain this to my class today, and a few students were having some issues. Students were thinking, like, okay, I should distribute this, x plus 1 cubed, and like expand it. Don't do that. Right? If you really wanted to get rid of this cube, how would you get rid of it? The cube roots. But guys, the cube root, the square root, the fifth root, whatever root you're doing of 0 is still 0. So ultimately, I just ignore those. All right? So what makes x plus 3 0? X equals negative 3. What makes, this might be a little tougher. If I move that over, what does it become? If I move the negative 1 over, it becomes 1. If you divide both sides by 2, then you get x equals 1/2. All right, what about this last one? What makes x plus 1 0? Negative 1. Now, that's part of the question. It also asks about multiplicities. So look at the factor, and this factor has a square. So x equals -3 is what we would call a double root. This one's triple over here. And then 1/2 is single. Right? Needs a date. Good now? Okay. Now, 2 and 3 are the same idea, but they're more challenging because they're not factored. So you have to factor some problems in 2 and 3.
Wait, can you do like 2? Wait, I forgot.
Do you want me to do 2? Yeah. Okay. Are we good on 1? Can I erase 1?
Mm-hmm.
Yes, Aiden, we're good? I can erase 1? Okay. All right. Let's do 2. Now, when I look at number 2, I immediately see that all three terms have x. What's the lowest exponent for x in any of those? X cubed. So I'm going to factor out x cubed. What's left when I factor out x cubed? X squared plus 4x plus 4. Very good. Now my brain sees x squared plus 4x plus 4 and thinks, oh, that's a quadratic trinomial. I'm going to factor this and ask myself, what two numbers multiply to give me 4 and also add to 4, right? They have to multiply to give me this 4, the last 4, and they have to add to give me the middle 4. So what two numbers do that? 2 and 2. And because they're the same number, I don't need to write x plus 2 times x plus 2. I can write it as x plus 2 squared. Bring down the x cubed, and now it's factored. So my two answers are x equals 0 and x equals -2. What kind of root is 0? It's triple root. And what kind of root is -2? Double root.
Wait, what happened to the x squared that was in the parentheses?
So this right here, this x plus 2 squared is x squared plus 4x plus 4. All right? Because if I were to multiply out x plus 2 squared, I would get x squared plus 4x plus 4. Sorry, that was double. Might be. Because it comes from, yes, I mean, this one is squared, so double.
Where did the first x come from?
The first x, I asked myself, what number cubed makes 0? What number cubed makes 0? Don't trick yourself, it's 0. I can do number 3, but I don't think I mean, it's factored by grouping. Do we need to do number 3? Yeah, okay. All right, let's do number 3. So factor by grouping. What do x cubed and -4x squared have in common? Actually, just x squared. So what happens when you divide that out? X minus 4. Now you'll notice plus x minus 4, this second group, has nothing in common. So what my brain does is I'm going to take out a 1. What's the sign in front of this term? It's positive, so make sure you take out a plus 1. All right, if you remember from when we did this probably a week or 2 ago, you take the stuff that you pulled out, and that becomes a factor. So x squared plus 1. And then this right here is going to be 1 factor. Okay, so what are the zeros? X equals 4 is a single root. Very good. Now let's see. Let's make sure everyone knows how you did that, Susanna. You move the 1 over. What does it become? -1. How do I get rid of x, that square? Take the square root. And the square root of -1 is literally I. And some of you, the first introduction to letter I happened in room 204 2 years ago. You were there, Peter. And you guys notice I put plus or minus? Now, what some students think is, oh, I is a double root, but no, it's not, because you have positive I, negative I. Those are just single roots. All right, do you see the difference? The x squared is inside. It still gave us single roots. When the square is on the outside, that's when it gives you the double root. So these are 3 single roots. I, negative I, and 4. That's 3 single roots. That's something that probably won't happen tomorrow, but that's a really good thing to know in your brain when you go to college.
Wait, so is that why the first x equals 0 and the other two is triple?
Yes, because it came from x cubed. If it had just come from x, it would still be x equals 0, but it'd be single. Everybody good? I think we should do 4 or 5, because it's still talking about the same thing, but with graphs. So which one do you want to do? 4 or 5? 5? Perfect. That's my favorite number. Let's do 5. Can I erase number 3? Aiden? Yeah, good. Okay. All right. Let's do 5. So 5 is the same idea, except they're giving you a graph. Now, when I look at this graph, I see 2 roots, 2 zeros, right there and right there. Now, when I write these, I'm going to write them as ordered pairs. So when I see a graph, I think ordered pairs. So I think the first one is 1, 0, and the other one is 3, 0. Do we agree? 1, 0, and 3, 0. Now, 1, 0 does not look interesting. It's just going right through it. Yes, everyone see that? So I think that's single. What's interesting about 3, 0? You see how it crosses, but it has that little kind of like, woo, before it goes? Do you remember what that means? It means it's actually triple. It's cubed. You could write that. That's fine. I prefer ordered pairs here, but I'm fine with that. Now, Yesenia, you said double. If you look at number 4, this root here, -2, 0, is double because it touches but doesn't cross the x-axis. That's how you know it's double.
If it's triple, it crosses the x?
If it's odd, if it's an odd numbered root, it crosses. So single root, triple root, quintuple root, septuple roots. Oh man, tomorrow should be fun. Bless you. I think we just did the whole first page, in essence. Yeah, done. Man, I hope one of those is on the test, right? We already did 6. 7's the same. Should we just do 8 or 9 and we just keep going? Cool, let's do 9. Number 9 is division again, but this time it's synthetic, so fake division. How do I know what number to put in the corner? The divisor, the denominator, and you want to think opposite. Think opposite, so -1. What am I going to write for my coefficients here? 0. Why'd you say 0, Jace? There's not a square term. You see how it's missing a square term? So you need that placeholder. So 1, 0, then 4, and 10. Good times, right? All right, should we go slow here? You want to go fast? Fast, let's do it. Okay, bring down the 1. 1 times -1 is -1. Add them together, you get -1. -1 times -1 is 1. 4 times 1 is 5. 5 times 1 is -5. Add them together and you get 5. Should I do it again slow? You said fast, Kayla. Faster than that? Yes. Okay. Let me see if I can do it faster than that. All right. Bring down the 1, multiply the -1, you get -1. -0 is -1 times 1 is positive 1. 5 times 1 is 5. 5 times 1 is 5. Add together, you get 5.
I feel like you just made up yeah.
Let's go slow. Bring down the first number and you get 1. Multiply by the number in the corner and you get -1. When I do synthetic division, I always think addition. With long division, I always think subtraction. Okay, so I'm going to add. Then I multiply again and get a positive 1. Add, multiply, add, and there's your remainder. All right, now that's not the answer because I need to write the actual quotient. So I started with x cubed. So what's going to begin my quotient? X squared minus x plus 5 over x plus 1. Now, if you look at number 8 on the key, I made a mistake on the key. You're looking at number 8. I think I wrote -1 and -60 is -6.
You put -6. I mean -6.
-6. What did I put?
Done it right, but it was like the answer. I guess you confused the 1 with the
With my
box,
bar,
but
yes.
it's a -6.
So you can see where I messed up. All right? My apologies. Deduct that from my pay. Okay. Everybody good on 8 and 9? There's definitely going to be long division and synthetic division on the test, for sure. One problem each. Now, here's where we ramp up the challenge, the level of difficulty. Number 10 and number 11. I think we should do number 11, because number 11 looks like there's more going on than number 10.
Is that what you did on?
Huh?
Is that what you did on?
On Tuesday. Yeah. No, we didn't do this on. We did this last week. Tuesday is when we did number 12 and 13. Okay. So, because this requires a lot and you have a whole page, what I'm going to do is I'm just going to end up erasing things, so make sure you stay with us. All right, don't fall behind. All right? So, what's the first thing I do when I try to find my roots for this polynomial equation? I need to look at factors of something. What do I want to find factors of? 12, the constant. What are factors of 12? Oop, I guess I should do that. 1 times 12. What else? 2 times 6.
3 times 4.
I think that's it, right? So there they are. 1, 2, 3, 4, 6, 12. Now, I had my students in my first period were giving me such a hard time. They're having a lot of trouble understanding how I wrote fractions as well. The reason that there are also fractions that could be the answer is because when you do this, it's not just factors of 12. It's factors of 12 divided by factors of the leading coefficient. Well, what are factors of the leading coefficient of 2? 1 and 2. So all these numbers divided by 1 are all those numbers. But all these numbers divided by 2 gives you an additional possible root of plus or minus 1/2 and plus or minus 3/2. So what I did there, if you're having trouble, was I took all these numbers and divided them by 2. What's 1 over 2? It's right there. What's 2 over 2? It's already there. What's 3 over 2? There it is. What's 4 over 2? It's already there. 6 over 2. There it is. 12 over 2. So that's why it looks like there's only 2 additional ones. Really 4 because it's plus or minus. I'm going to tell you right now, tomorrow, I'm not going to take out points if you forget to put the fractions. All right? Because ultimately, this is just helping you figure out where to begin. All right? And where do we want to begin? At 1. I'm surprised no one said at the beginning. And we hope that this 1 is going to be a root. And it's 0 at the end, yes.
You're already giving us a hard time with that, so I think we should try to.
You want to skip 1?
No.
I wouldn't. Remember, who made the test? I did. The teacher. Thanks for that.
Are we going to do synthetic division?
Absolutely, you should. All right, let's see if we get a root. Bring down the 2. 2 times 1 is 2. Add them together. And -15 times 1, -15. I think that's going to be 31. Yes. Yes! Awesome. That's exciting. We found one. Just 3 more to go.
Wait, what?
X to the 4th power. Forwards. Don't you worry, I got you. We still got enough time. All right, so
Wait. We gotta find out the power?
you're trying to find the values for x that are going to make this 0. And whatever the highest exponent, the degree, that tells you how many answers you should have. So we need 4 answers. All right, when I write 1, which was my first answer, as a factor, you want to think opposite. So you see why I wrote x minus 1 there? I want to think opposite. Now, what am I going to write is remaining here? 2x cubed plus... Now, what I tried to tell you guys when you were 2 years younger than this, 1 year for some of you, is that even though it looks different, this right here, the x minus 1 times 2x cubed minus 15x squared plus 31x minus 12, is the same as this, what we started with. We've just begun factoring it. Now, if the gods are nice, when I look at what I have remaining, I'm hoping I can factor by grouping. But when I look at this, what do 2x cubed and minus 15x squared have in common? X squared. So I would have remaining 2x minus 15. What do these have in common? Nothing. So when I take out a 1, they have 31x minus 12 remaining. Is that the same as 2x minus 15? So we can't factor it. So then it comes down to, well, what do we do next if we can't factor it? You keep going. Now, be careful here. This is where students will mess up. We used 1 and got 1, and you want to skip it. What's after 1? Negative 1. But I'm not using 2, negative 17, 46, negative 43, and 12 anymore. I'm using 2, negative 15, 31, negative 12.
For what?
For negative 1. I don't use 1 again because it's going to give me a 0. I already know it's a 0. Now I'm using negative 1. But what happens is students go back to the original coefficients, and you should not. Once you get a root, it's like, bye-bye, don't care about the original anymore. Now I care about this new one. Say it again? Okay. Bring down the 2. Thank you. 2 times negative 1 is? Add them together. Negative 17. Multiply. What was that? 48. Sad. That's not 0. You knew it. But no, you didn't. So that means I'm trying which number next? Positive 2. Come on, math gods. Let it be a root. Let it be a root. Nope, that's not what the Beatles meant. Okay, bring down the 2. 2 times 2 is 4. That's negative 11. That's negative 22. Oh, not looking good. What's that, negative 30? Okay. Come on now. Let's try negative 2. Now I'm going to erase, but you should keep going. All right, so we're going to try negative 2. Is that negative 19? Was that 38? Oh, no. Oh, my gosh. That's not even close. What is that? Negative 150? Woo! Okay. Running low on patience here, problem that I made. So what's the next one? Please, let it be positive. You think it's going to be a fraction? Ye of little faith. 2 times 3 is 6. Negative 15 plus 6 is negative 9. That's negative 27. That's 4. 4 times 3 is 12. Woo! We got it. We got our second one. Only 2 more to go. Okay. So what I'm going to do is keep writing. What do I want to write this? I'm going to erase that because we're done with that. Okay, and I'm going to erase this. All right, which one did we already write down? What was our first root? X minus 1, right? What is this going to be? This is another root. So what am I going to write down for this factor? X minus 3. Always think opposite. Times. Now this started from what? Right? We already had x to the 4th. We got this one. So these were x cubed. So then this is going to be 2x squared minus 9x plus 4. All right. Now it's time to factor. And then we'll be done. Now, when I taught you guys how to factor this, I just told you to like guess and check. Do you guys remember when I said use the OI? Yeah. So I've decided to change the way I teach this. All right. After watching Mr. Goldsberry, I like this way better. So if you have Mr. Goldsberry, maybe you'll see this. Here we go. I'm focusing on 2x squared minus 9x plus 4. All right. This is called a quadratic trinomial, and it has a coefficient that a, the very first number, is not 1. So if it's not 1, I want you to multiply a, which is 2, and c, which is 4, the very last number and the very first number. What's 2 times 4? So they need to, these two numbers need to multiply to give me 8, and they have to add to give me the middle number. That's letter B. What's the middle number? Negative 9. Can you think of two numbers that multiply to 8 and add to negative 9? Eight and 1 is what most students say, but that won't give me negative 9. Negative 8 and negative 1. Because when you multiply the negative and the negative, it will become positive. But when you add them, you get negative 9. Now watch how I write it. The 2x squared is the same, but then I want you to write plus, and in parentheses, negative 8 plus negative 1, close it to get x. Let me see if your brain sees what mine does. I want this to still be negative 9. So what is negative 8 plus negative 1? Negative 9. So I'm trying to show you it's the same thing. Okay? Bring down the plus 4. I'm going to pause here. Everyone okay? Ask if you're like, what? Just let me know. Okay. Now, do you see this x is being multiplied by both of these? Let's distribute it. What's negative 8 times x? What's negative 1 times x? And the moment I get here, my brain says, nice work, Douglas. Factor by grouping. Okay? So I'm going to group the first two and the last two. What do 2x squared minus 8x have in common? 2x. What's left when you take that out? They don't have squared in common. They both have a 2x in them. 2x squared and negative 8x both have a 2x. Right, 2 can go into 8. X go into x. So what's left? Close. Did I hear x minus what? Oh, okay, that's it. My bad, sorry. All right. What about the other group? Negative x plus 4. Do they have anything in common? No. All right, so you're going to take out a 1, but what's the sign in front of this third term? So you need to take out not just 1, but -1. And that will allow you to get the same factor. All right, so just like we did on number 3, I believe, your two factors are 2x minus 1 and x minus 4. Do you remember these two that were up here that I haven't touched in a while? They're coming down. And now I can get my 4 answers. I know x equals 1, x equals 3, x equals 1/2, x equals 4. And oh my goodness, all 4 of those answers are up here. All 4 answers were just sitting up here the whole time. Huh. All right, give me the questions, concerns. What do you got?
There's gonna be no like this one.
Yeah, 25% of your grade tomorrow is going to be on this question.
This long.
It's amazing, right? I love it. I still remember when my teacher in high school gave me one that was x to the 7th. It was awesome.
What's our
X to the 4th on this problem. I'm not going to tell you what it is tomorrow.
How much time do we have tomorrow? Like,
42, 44 minutes, something like that. I cut off questions, so you'll have time.
no, but I still just wanted to know.
Something like that. Remember, this is the last class before for prom. So, gotta be here. Tomorrow's a Wednesday schedule. Somebody said, can we try 14, I think I heard? Okay. What is number 14? Is that the slant asymptote? You're good. That's not on the test tomorrow. The slant, all that is long division. When it says find a slant asymptote, just use long division. It's not. But like all it is, I mean, it is and it's not, right? Long division's on there. Finding a slant asymptote is not, but finding a slant asymptote is just using long division. So we're good there. So 12 or 13? Okay. Tuesday. Yeah. So which one do you want to do, 12 or 13? 12? Okay. All right, let's do 12. The first. Tuesday. The first thing I noticed in number 12 is that we can factor. What do 3x squared minus 27 have in common? They have a 3. Okay, what about the denominator? This is a quadratic trinomial, but what's the first number? What's letter A? It's a 1. So do I need to use that method I just showed you? No, I'm just going to ask myself, multiply to give me the last term, -2, and add to give me the middle term. What's the middle term? +1. So what two numbers make that true? Or -1 and 2. Let's see if we agree. Do we agree? -1 times 2 is -2, and -1 plus 2 is what? I agree. So we can write that down. X minus 1. Ooh, if you did -2 and +1, when you add them, it would give you -1. So that's why it's not -2 and +1. Good question. All right. Do you know how to factor x squared minus 9? My goodness, I hope so. Great. Does anybody remember what x squared minus 9 is called? Sylvester again. No one just won. Come on. Not only Sylvester that knows this. The difference of 2 squares. Okay. We went over it. Dots. Difference of 2 squares. No? Okay. You did it with Dr. Lara too. Probably. She's sad. I'm gonna send her a Facebook message. What's up?
I forgot about her.
You forgot about her? She's still alive. She's still teaching. Okay. What do we do now? Because that was fun, but that literally didn't answer any questions. We gotta find this stuff.
The bottom one's equal.
Okay, the bottom one's equal to 0. What would that give me? What if I make the denominator 0? Not the x-intercepts. Very good. We can do that one first. I don't really care. So vertical asymptotes are going to be x equals whatever makes the denominator 0. So what makes the denominator 0? 1 and negative 2. So x equals 1 and x equals negative 2.
Can you just put a comma?
That's fine. I like to do that so I know in my brain there's two separate ones. Okay? Who knows how to find something else? We still need other stuff.
Your horizontal.
Ooh, the horizontal asymptote? No. You got me. What you said was to find the y-intercept.
Yeah.
How do you find the horizontal asymptote? About the degrees. What is the degree of the numerator? The degree of the denominator? They're the same. Do you remember what we do when they're the same? You write y equals, and you look at the leading coefficients. So I see 3, and I see 1. What's 3 divided by 1? 3. Boom. Take a quick pit stop over here. What's the degree of this numerator? Denominator? What happens when your degree of your numerator is less than the degree of your denominator? It's y equals 0. Make sure you know that for tomorrow. It's on the notes from 5-6. I think it's the very first slide. Absolutely. When the degree of your numerator is less than the degree of your denominator, the horizontal asymptote would be y equals 0. The other way around, what if this was squared and that was x? That's when you would find the slant asymptote. And you would do long division to find it. Which you don't have to do tomorrow. You're welcome. But you do on 15, sure. Really, if you wanted to know, you'll look at my answer key. Should we just pull it up right now? Actually, let's wait. Let's wait till I finish this, then we'll pull up the answer key and I'll show you the difference in slant asymptotes. Okay, what else? I think let's do the y-intercept because you said something about the y-intercept, right?
Yeah.
The y-intercept is you make x 0. So we have 3 times 0 plus 3 times 0 minus 3 over 0 minus 1 times 0 plus 2. Okay, so what's 0 plus 3? 3. 0 minus 3. So I'll multiply, we got a 3, and a negative 3. 3. It is negative 27. Over 0 minus 1 and 0 plus 2. Multiply those and you get negative 2. So it's going to be a positive 27 halves. Or 13.5. I don't care. Fraction's fine. Everybody good on the y-intercept? And finally, the last thing we haven't found yet is the X-intercepts. How do you find the X-intercepts? Make the numerator become 0. So in the numerator, I have x plus 3 and x minus 3. What makes those 0? Negative 3 and 3. And if you wanted to write x equals 3 or x equals negative 3, that's fine. Whew! Man, that was fun. Yes, x-intercepts is what makes the top 0. Yes, Yesenia. You equal them to 0. So my brain, I didn't write it down, but my brain did this. My brain did x plus 3 equals 0 and x minus 3 equals 0 to get each of these. All right, the numerator.
Oh, okay.
Sorry, I'm using the factored one.
Okay.
That's the one I care about.
And for y-intercept, you put in all the-
Y-intercept, this is the work for y-intercept down here. Yeah, you plug in 0 for x. Make sure you know that. That will definitely be on the test. Definitely. Okay, let's talk about the slant asymptote. Can I show you the key for the slant asymptote? I'll wait till everyone's finished writing. Good. Everybody finished writing? Yeah. Okay. So if you go to the key, and I go to the slant asymptote. Where's that? Slant. There it is. So all you do, so do you guys see how the degree of the numerator is greater than the degree of the denominator by 1? That means you'll have a slant asymptote and you will not have a horizontal asymptote. So you have no horizontal asymptote, but you have a slant asymptote. So it'll be like a line. Like, let me show what I mean. So like you're going to have a slant asymptote like this. So slant just means it's not up and down or side to side. It's slanted. Now, do you take a look at the work that I did? And you'll see ultimately it's the same work that we've been doing, but you'll notice I wrote here, when you do slant asymptotes, you just ignore the remainder. All right? So I didn't need to write 2x minus 1 minus 2x plus 5 over x squared plus 1. That'd be the remainder. I just care about my linear equation, mx plus b. It will be a line every time. And you want to know why it's a line every time? Because if this numerator has a higher degree by 1 compared to the denominator, when you divide, you'll always start with x. Right? Because x cubed over x squared will be x. X to the 5th over x to the 4th is x. So that's why it has to be greater than by just 1. Will this be on the test? No. Do you need to know what happens when the degree of the numerator is less than the degree of the denominator? Yes. That's y equals 0 for the horizontal asymptote. And what happens when they have the same degree? It's y equals the ratio of the leading coefficients, that fraction. No, you're not, Yesenia. No, you're not. All right, then. We still have 10 minutes. Should we take a look at, the only one we really didn't talk about is 10. Should we just like look at the key and make sure we feel comfortable? It's the same as 11. It's a little different. You can almost see all the problem. Almost. Should I zoom out just a little bit? Okay, that's close. All right, anybody see any questions? We didn't get our first root until -2. It took me 4 tries to get a root. Do you think you could factor a quadratic trinomial tomorrow that has a coefficient that's not 1? If you're shaking your head, you should put in some time tonight. It's a 4. Sorry. 4. 4.
Minus
4. 4. Hey, let me zoom in on this because this is the hard one. So this is, I looked at -4 times 2, which is -8. So it has to multiply to give me -8 and add to give me -7. So the two numbers that make that true are -8 and 1. So that's why I put them in here for that method.
Oh, so you multiply the A and C?
Yes, you multiply A and C. That's what it has to multiply to give you. And then you look at B, the middle term. That's what it has to add up to give you. All right, if you want to Google it, it's called the BOMB method. B-O-M-B, because like back in the 90s and early 2000s, people used to say like, oh man, you're the bomb. No? Am I too old for that? You guys are too young? And then like if you want to like go even like hashtag extra, you say you're the bomb.com.
We did that.
You did that in middle school? Okay. I don't know what that is. I walked in the same time you did and saw the pineapple and that other words. Recording.
Oh, did you want them to hear?
No, I don't. Shh. We're having technical difficulties.
That's it. What's wrong? All of a sudden.
All right, thanks for watching.